Logical topologies define how our data moves on the network. So the way our network acts and the way our network looks may not be the same. The first logical topology that we'll discuss is the logical bus topology. Logical bus is very similar to physical bus in that when computers communicate, each time they send their data out onto the wire, all of the other computers get to see that data. The computers also have to compete for network access. So if this computer is sending information through the hub, all of these other computers will have to wait their turn until that computer is finished communicating. Now, depending on our central connecting device, our network might act a little bit different. If we were to turn this hub into a switch, we wouldn't have to compete for network access anymore. Each computer would be on what's called their own contention domain. And contention just means that we all have to compete for network access. So depending greatly on your network connecting device, your computers are going to communicate better. As far as the benefits and the drawbacks, Logical Bus is great because it's easy to set up and easy to use. The major drawback is still staying with the physical star. We have that central point of failure with our central connecting device. The Logical Bus topology, when used in conjunction with the physical star, is called Ethernet. And Ethernet is the most common network seen today. With our logical ring topology, computers communicate much in the same way they would in a physical ring. Our computers will send their traffic through that central connecting device, and it will loop to each computer in the logical ring. Now we have our current logical ring set up with a physical star. This is currently the most common implementation of our ring networks. This central connecting device is a lot different from what we might see in a logical bus environment. It's called a multi-station access unit, and it has some special features built in. For example, if this computer failed, under a physical ring topology, our entire network would go down. But because we've moved to a physical star, our multi-station access unit will close this port off and allow the ring to continue to flow in the correct manner. Now these computers will put their data on what's called a token. That's why this type of network is commonly referred to as token ring. So our computers will apply their data to the token and pass that token around. Some of the benefits of our logical ring topology when put in combination with a physical star, and depending on the media used or the cabling between the computers and the multi-station access unit, we can get some very high-speed data transfer with very, very reliable networks. But because it is physical star, we're again faced with that problem of the central connecting device failing. In our next logical topology, called the logical star, we have several computers that will send their data signals to a transceiver. This is also called a multiplexer. A common example of what you would see as a multiplexer might be a cable modem. So we're going to take all of our data signals from these computers and we're going to convert that data signal into a single data signal that will pass over the network. Now this can be very beneficial because you can choose which computer will gain access to the network at what time. So depending on our priorities assigned to our computers, computer 1 might get access to the network even though computer 2 was trying to access it before. This is called a deterministic based media access method because the transceiver or the multiplexer will determine who gets network access. This can be greatly beneficial because one computer might control a very important process in a plant, and we would want that computer to get its network traffic quicker than, let's say, the receptionist at the front desk. Again, because we're using logical star on physical star, we're still faced with that problem of the central connecting device failing and causing the rest of the network to go down. But our transceiver is intelligent enough, if a single computer fails, it will just close off that computer's port and the rest of the computers will be unaffected. This should give you an idea of how the logical topologies integrate with physical topologies. Almost all of your networks in place today will fall under one of these logical and physical topologies. Next, we'll discuss network categories.